MS Ramaiah University of Applied Sciences.
Hi students, title of the experiment is Study of SSB Amplitude Modulation System. Aim of the experiment is to generate double sideband suppressed carrier DSB-SC amplitude modulated wave, to generate single sideband SSB amplitude modulated wave, to demodulate the DSB amplitude modulated wave. Amplitude modulation refers to the modulation technique where the carrier's amplitude is varied in accordance to the instantaneous value of the modulating or baseband signal's amplitude. In a DSB amplitude modulated wave, there are two sidebands in the frequency spectrum along with the carrier signal. If the carrier frequency is not allowed at the output, it is called DSB with suppressed carrier, DSB-SC amplitude modulation. If only one of the sidebands is allowed at the output, such a modulation is called SSB amplitude modulation. SSB modulated wave occupies less bandwidth compared to DSB amplitude modulated wave. The block diagram for AM transmitter kit which supports SSB modulation is shown here. The block diagram for AM receiver kit which supports SSB demodulation is shown here. The apparatus required for this experiment are Syntec 2201 kit, Syntec 2202 kit, power supply, CRO, connecting wires and probes. Procedure: provide message signal input from audio oscillator. Adjusting its frequency and amplitude, observe the message signal in CRO. Select the SSB track. Tuning the balance knob in the balanced modulator, observe the amplitude modulated output in the CRO. Tuning the balance knob, suppress the carrier and observe the output amplitude modulated wave. Also, observe the SSB output after the balance modulator and bandpass filter blocks. Provide the output of transmitter kit to the input of the receiver kit and observe the output from the audio amplifier by selecting the diode detector path. Adjust the tuning circuit knob and compare the output of audio amplifier with the message signal. Note that the transmitter and receiver kits should be connected to a common ground. The expected waveforms are shown here. In the left waveform, message signal is at the top and corresponding DSB-SC signal at the bottom. In the right waveform, SSB waveform is shown.
Hi students, the name of the experiment is Study of SSB, that is Single Sideband Amplitude Modulation System. In this experiment, there are three parts of the aim. First, we will generate double sideband suppressed carrier wave. Then we will generate SSB wave, that is single sideband modulated wave. Then we will demodulate single sideband modulated wave. The apparatus required for this experiment are: this is Syntec 2201 AM transmitter board. It supports double sideband and single sideband modulations, amplitude modulations. In this experiment, we will use this kit for single sideband, that is SSB modulation, and also for DSB-SC modulation, double sideband suppressed carrier modulation. This is Syntec 2202 kit. This is AM receiver kit. It also supports double sideband and single sideband modulations. In this experiment, we will use this for SSB demodulation. CRO. This is CRO. In this CRO, we have two channels. These controls are for channel 1. These controls are for channel 2. Channel 1, we have to provide input through this. Channel 2, input should be provided through this. These two are used for position control, and even this one can be used for position control. This is time scale. These are voltage scales. This is the on and off button for the CRO. Connecting probes and connecting wires. These are the connecting probes which are used to connect from the kit to the CRO. These are the connecting wires to interconnect different places, different nodes of the kits. Now let us start the experiment based on the block diagram. First, switch on the power supply. Make sure this is glowing. This part represents an audio oscillator. Here we get the message signal. These two are the controls for frequency and amplitude of the message signal. From here, the signal goes to either this track or this track based on the selected switch. So select the switch such that SSB is taken. Now the signal enters this path wherein we have three blocks: balance modulator, band pass filter, balance modulator and band pass filter. So this is one stage and this is second stage. Balance modulator and band pass filter, this is stage 1 and this is the same thing but stage 2. So here we will have the SSB output, and from here the SSB output should be selected properly. So press the switch, SSB track gets selected and this amplifies. This is output amplifier. SSB wave is amplified in this and the amplified output is either given to antenna or to the socket. We will use socket. So the output is available here. Now we will connect CRO probes and check message and output in the CRO. First switch on the CRO. Meanwhile, take one connecting probe, CRO probe, connect it to channel 1. We will use this for message checking. Take another CRO probe, connect it to channel 2. We will use this for carrier as well as output checking. Next, take a connecting wire and connect this to the ground. Now, in both the CRO probes, connect the negative to the ground. So this is first channel, this is second channel. We use this for message checking. So we will put this at the message output of audio oscillator and observe the CRO. So the message is visible. As we change these two knobs, the frequency as well as amplitude of the message signal can be changed. So set the frequency to 2 kilohertz or any suitable frequency can be set, and then press an auto set. Now let us check whether the carrier is generated. So this is the carrier generator. So it is available here. And now in the CRO, by changing the time scale, you can see that the carrier is generated. Carrier is very high frequency compared to message. So hence carrier and message, full sine wave of the message and full one cycle of carrier can't be observed in the same CRO. So now we will remove this and connect this to the SSB track. So first the message goes here, so I will put this here. Now this belongs to DSB-SC output, double sideband suppressed carrier output. After connecting this here, first press an auto set in the CRO. You can observe that there is an over-modulated, amplitude modulated wave here. Now by adjusting the balance, we can change the waveform. So now this is 100% modulation. So now here we will suppress the carrier. For that, these lines should be followed. First you should make the audio oscillator amplitude as 0. So this is the fullest anti-clockwise. It represents 0. You can see that in the CRO there is no message signal at all. First channel belongs to message, so it is absent now. So now whatever is available here, you can increase the scale. So you can see that this is purely carrier which is available in the second channel. Now the balance knob here has to be tuned such that it becomes 0. So you can decrease the voltage scale and make this 0, almost 0. This is more. So this is almost 0. Now put the message amplitude back. Now again give an auto set. So this now represents a DSB wave without a carrier, DSB SC. This DSB SC is next passed through a band pass filter, and next we have one more stage. We will now check the output here. SSB output takes only either the upper sideband or the lower sideband. So here it is tuned to FC plus FM, that is upper sideband, and the tuning, after tuning it is again passed through a second band pass filter so that the rejection of the first band, that is lower sideband, is very good. So now after complete rejection of the lower sideband, only the upper sideband is available here. So hence SSB output looks like a sine wave, perfect sine wave. So you can increase the scale and you can see that this is, you can run stop it, you can see that this is a sine wave. So unlike a DSB wave where we observe different types of envelopes, here the envelope is a straight constant line. So it's a perfect sine wave. Now we give this SSB wave, SSB output to an SSB receiver and check whether we can retrieve our message back or not. Now take the Cytec 2202, that is AM receiver kit. As already mentioned, this is supporting both DSB and SSB demodulation. First, power up this, switch on the power supply, make sure this LED is glowing and select, see here there are two tracks, either antenna output or the receiver input can be selected. We will use receiver input from here. So take a connecting wire and connect from the output of transmitter to input of the receiver, and make sure the grounds are common. So the ground of the receiver and the ground of the transmitter have been common. Now take the probe, CRO probe from the transmitter kit. This we were using to observe the output waveform. Now keep this in the receiver. First connect whether the output is coming or not can be verified. So first put the CRO probe here. Take another connecting wire if necessary and support it to connect the ground of the CRO probe. So now we will release this run stop which we have pressed earlier and press an auto set. You can adjust the scale. You can see that the sine wave SSB modulated output, which is a sine wave, is available here now. So the output of transmitter is successfully given to the input of receiver. Now the output now passes through RF amplifier stage, mixer, IF amplifier 1 and 2. RF frequencies, radio frequency is high frequency mixer will down convert it to 455 kilohertz, which is called as IF frequency. IF amplifier, the output which is IF frequency, that is amplified in 2 stages, and the output goes to 2 stages, either diode detector or to the product detector, and the detector can be selected using this switch. So press the switch such that now product detector gets selected. For SSB demodulation, we can use product detector. We can't use diode detector because it is envelope based, and in SSB our envelope is constant, so hence we can't use this. Product detector indeed can serve as a detector. So first select this such that the product detector is selected. Now connect the CRO probe to the output. After the output of the detector, it is going to audio amplifier. Amplifier output is available here, and this is selected to the load, so it can be verified here. So put the output here and press the auto set in CRO. Now you can see that there is no wave, so now you have to tune RF amplifier knob, then the tuning circuit knob, and also the audio amplifier knob, such that the output and this input message are the same. So before tuning these 3, first this is not a diode detector and it's a product detector, hence make sure that the beat frequency oscillator is selected. Right now it is in off condition, so press this so that this is on, and now start tuning the 3 knobs. So you can observe the CRO as I tune the knobs. Press and run stop if necessary. You can overlap the 2 waveforms. Adjust the amplitudes. And continue tuning. So you can observe that now after tuning, both the input and output are almost the same. However, you can adjust the time scale and verify. Press an auto set and you can overlap the waveforms. Try tuning. As you tune, you can observe that almost the input message and the demodulated message are almost the same. So this says that the demodulated waveform of the SSB demodulator receiver kit is same as the message signal that we have provided for SSB modulation. So hence the SSB modulation system, the SSB amplitude modulation system has been verified. This concludes the experiment.
At MSR UAS, we spark your imagination unlike any other.